Hi Math 8, this is Mrs. Cowles, and today's lesson comes from your textbook, Lesson 3-5, Write an equation and make a graph. For each situation, define the variables, write an equation, create a table of values, and graph a linear function. Be sure to label the axes. So our goal today is to take a situation and create an equation for it, be able to create a table for it, and to make a graph. So let's read problem number 1. To visit the zoo, you must pay $12 per person. Write a function that shows the total cost for any number of people. So to write a function is basically asking you to write an equation. So when we see write a function, they're asking us to write an equation. Okay. Now, we've been writing linear equations in class. We've been writing the form y equals mx plus b, where m is our slope and b is our y-intercept. X and y are variables in our equation, and x is our input, which is the independent variable, the variable that can stand alone. Y is the output, which is the dependent variable. Y depends on whatever you plug in for your x. So as we read the question for number 1, it says write a function that shows the total cost. So let's circle total cost for any number of people. So those are our two unknowns in our story, the total cost and the number of people. We have to determine which one is going to be represented by x and which one is going to be represented by y. So we have to think about it. Does the total cost depend on the number of people, or does the number of people depend on the total cost? If we think about it logically, cost depends on the number of people. You're not going to know the cost of your trip to the zoo unless you know the number of people. Are you able to know the number of people in your group without knowing the total cost? Yes, you can always just count the number of people. The number of people is your independent variable. It can stand alone. You do not need to know the cost in order to know the number of people. So our independent variable is going to be number of people. And our dependent variable is going to be the total cost. Again, cost depends on number of people. So we're going to go down below, and what we're going to do is let's fill in our table. We have a table where we have an x and a y column. Again, we established that x represents number of people. And y represents the total cost. And you gotta love the stylist handwriting. Okay, so if we go to the zoo and we go back and read the problem, it says, to visit the zoo, you must pay $12 a person. So if 0 people go to the zoo, what's your cost going to be? $0. But if 1 person goes, the cost is going to be $12. 2 people go, the total cost will be $24. 3 people go, the total cost will be 12 times 3, 36. So let's go over and we are going to plot these points on our graph over here. Make sure you label your axes. To help us with that, we look at our table. X, our x-axis over here, is represented by the number of people, so we're going to label that people. Our y-axis is the total cost. So the first ordered pair we're going to plot is 0, 0. The next ordered pair we're going to plot is 1 and 12. For 2 people it was 24, so we'll plot that point. And for 3 people it was 36. Now, we are not going to draw a line in this situation to connect the points because this is an example of a discrete situation. We have to use whole number of people when we are talking about a trip to the zoo. If we connect a line, then we could find a representation for what the cost of 3.5 people would be. Obviously, and I hope we wouldn't have part of a person when we're going to the zoo. So now let's go back and we need to establish an equation for the situation. If we go back to set up an equation, we're going to set up an equation starting with y equals, because we are calculating our output. In this case, our output y represented our total cost. If you'd like, if it's helpful, go back and write cost above your y to remind you that's what y was. Now, how are we going to calculate the total cost for the zoo? If we go back and read, it says it's $12 per person. Per person. That literally means every person is going to pays $12 a piece. Instead of writing per person, we can use the variable x, because x stands for the number of people. So we can actually think of this as $12 for every x. So the cost is going to be $12 for every x. Now if we take a look at it, this equation is pretty much in slope-intercept form, or y equals mx plus b. And if we think about it, our m would be 12. And our y-intercept, even though we don't see it, we could always put a plus 0. And if we go back and look at our graph down here, our y-intercept was at 0. So now, as we continue to work through these problems, we are going to use this equation up here to answer part A and B. So how much does it cost for 8 people to go to the zoo? Well, we know there's 8 people, so to find the total cost y, we take the $12, we're going to multiply it by 8, 12 times 8, total cost is $96. Now, let's take a look at part B. It's a little different. Here the total cost of the zoo trip is 132 people. How many people went? Here we got to work backwards. We know the cost. We got to figure out how many people went. Common sense for many of you is going to say divide by 12, and that is correct. Here is the reasoning why. If we use our equation, our cost is y, and that's equal to 12 times x. X is the number of people. $132 is equal to 12x. So to solve for x, if we divide by 12, when we do 132 divided by 12, we find that x is equal to 11. So a trip that's $132 means there are 11 people at the zoo. Okay. All right, let's take a look at the next problem. Okay, so we're going to hit next. And I'm not sure why it's not going. Alright, so let's take a look at question number 2. To take your new puppy to puppy school, you must pay a $10 registration fee plus $4 per class. Write a function that shows the total cost for any number of classes. So once again, we are asked to write a function that shows the total cost for any number of classes. So we're talking about total cost and number of classes. Once again, we had to figure out which one's going to be represented by x and which one's going to be represented by y. So as we read this, which one depends on the other? Does the total cost depend on the number of classes, or does the number of classes depend on the total cost? Which one can stand alone? Which one can you know without knowing what the other is? The answer to that is the number of classes is independent. You do not have to know the total cost in order to know the number of classes you sign up for. So independent is number of classes. Your dependent variable is going to be cost, the total cost. So we're going to go down here and we're going to label our tables. X is number of classes. Y is the total cost. And let's go back and read the problem again. To take your new puppy to puppy school, you must pay a $10 registration fee plus $4 per class. So before you even actually take any classes, what's your total cost going to be? Well, if we go back and read, it says we have a $10 registration fee. So without even taking any classes yet, you first have to pay $10. Then we're going to take one class. So if it's $4 for one class, that's $4. We add that back to 10. Our total cost is going to be $14. For two classes, it's $4 per class, as we see that up here. So 2 times 4 is $8 for two classes, but we have to add that to the $10 registration fee. That's going to be $18. Some of you are going to start to see the pattern that we're adding 4 to our Y column, and that it holds true for the last one as well. 3 times 4 is 12, so it's $12 for 4 classes. We add the $10 registration fee, that's $22, which we also could have gotten by adding 4. So come over here and you're going to graph your ordered pairs. We have 0 and 10, 1 and 14, 2 and 18, 3 and 22. Once again, we can see we have a linear pattern that occurred. So let's go back and write the equation. Because we see the linear pattern occurring, we should have a linear equation. So we start our equation with y equals. Again, what does y represent? It's our total cost. Now, how are we going to represent our total cost in this case? When writing an equation, the first thing we want to think about is there a flat fee or a certain rate or a certain starting amount that occurred? In this case, we start out having a $10 fee. So we're going to write that first. And then we're going to add to it, if we continue to read, it's $4 per class. That literally means $4 for every x, because classes is represented by the variable x. So we can interpret this as $10 plus $4 for every class, or $4 for every x. We'll notice that this is actually in slope-intercept form. It's just written a little out of order. If you want, you can even rewrite your equation. It's y equals 4x plus 10. We'll notice that our slope is 4. We'll notice that our y-intercept is 10. If we take a look at our graph down below, the y-intercept is 10, and we see that that actually crosses at 10. The slope is 4. If we were to do our rise over run, we see we go up 4 and to the right 1 to get from every point, up 4 and to the right 1. We also can take a look at that in the table as well. If we find our change in y over our change in x, we're going to see that our slope, our change in y, we saw was plus 4 all the way down. Our change in x, if we look, it's plus 1 all the way down. Our change in y was 4, our change in x was 1, our slope was 4. So again, we can see the relationship of the slope occurring in the equation, the table, and the graph. Now, as we continue to work on these problems, you're going to see I forgot to label the axes on the graph. So again, it's always important to label your axes. X represented the number of classes. And again, excuse the handwriting. The stylist can't write very well with. Number of classes. And then we have on our y-axis, once again, that was the cost. All right, so let's move down. How much will it cost then to send your puppy to school for 7 classes? So we want to use our equation to answer this question. It's $10 plus $4 for every class. So if we know we're going for 7 classes, we can plug that in for x. So to calculate the total cost, it's 10 plus 4 times 7. Now if you're doing mental math, you got to be careful. Order of operations says to multiply. 4 times 7 is 28. We add 10. The total cost is $38. So if you go to class 7 times, your total bill is going to be $38. For part B, your puppy, the cost for your puppy class is $30. How many classes did your puppy go to? So we still want to use our equation to help us with this. The equation is $10 plus $4 for every class, and y is our cost. Well, the cost for your puppy's classes is $30. So we're going to plug that in for y. Now we can solve for x. So we're first going to subtract 10. That's like saying we're going to subtract the registration fee out of the $30. So when we subtract 10, that leaves us with 20 that we are going to now divide up among 4 classes. I'm sorry, that we're going to divide up among the $4. So if we had $20 and each class is $4 a piece, 20 divided by 4, x is going to be equal to 5. So if your bill is $30, you are going to have 5 classes. Let's take a look at question number 3. If you think you can do this, pause it and write up your answers and then come back and check and see what you have written, how it compares to what I'm about to do. To order blue team t-shirts, Mrs. Dexter must pay $4.50 per t-shirt plus a one-time fee of $20 to put names on the back of the shirts. Write a function that shows the total cost for any number of t-shirts with names on the back. So we are asked to write a function, shows the total cost for any number of t-shirts. So our outcome or dependent variable once again is total cost. Sometimes that's going to be key too. When you see the word total, whether it's total height, whatever total you're calculating, that can be a Q or a sign to you, that's going to be your output or your dependent variable. Independent is going to be number of t-shirts. So let's label our x and y axis while we're at it. X is the t-shirts and y is the cost. Okay, so we're going to fill out our table. And again, we want to make sure everything is labeled. This is t-shirts. How many t-shirts do you have? This is your cost. And let's figure out the cost if you have 0 t-shirts. If we go back and read the story, Mrs. Dexter must pay $4.50 per t-shirt plus a one-time fee of $20. So if we have that one-time fee of $20, that means before we even order any shirts, our cost is going to be $20 because you have to pay the one-time fee. Now when you order one shirt, the one shirt is going to be $4.50. You're going to add that to the 20. So if you only order one shirt, your cost is going to be $24.50. If we order 2 shirts, well, at $4.50 per shirt, 2 times $4.50 is $9. If we add that to the sign-up fee of $20, it's going to be $29. Now some of you are going to start to see the pattern that as we go down, we're just adding $4.50 every time. So for 3 shirts, it's $33.50. Oh, that doesn't look good. Let's fix that. Okay. All right. So go over to your graph. You're going to plot that. 0's at 20. 1 is at $24.50, so that's just going to be just below 25. Again, I got a chunky stylus, so it's hard to get this exactly. 2 is going to be just below 30 at 29. And then 3 is going to be at just above 30 at $33.50. Once again, you see you have your linear pattern forming. So to write the equation, we're calculating the cost, y. Well, let's go back. Is there a starting amount? Yes, you have a starting amount of $20. And then what do you add to that $20 every time? $4.50 for every shirt. So that's $4.50x. Let's make that nicer a little bit as best I can. Once again, we can see this is in slope-intercept form. Our slope is in front of x, it's $4.50. Notice when we went down the y column, we kept increasing by $4.50 every time. And our y-intercept's at 20. If we look at our graph, we see we're crossing the y-axis at 20. So let's use the equation to answer the questions. If there are 15 people on the blue team, how much will Mrs. Dexter pay for the shirts? So 15 people on the blue team, how much will she pay? So if there's 15 people, that means there's going to be 15 shirts. So we're going to use our equation. Y equals $20 plus $4.50 X, and for X we're going to plug in 15. So to calculate the total cost, it's going to be $20 plus $4.50 times 15. So you guys go ahead, you put that in your calculator, and you're going to find out that that's going to be a total of $87.50. Now, if Mrs. Dexter pays $132.50 for the shirts, how many did she purchase? This time we're looking for X. How many did she purchase? So we know the cost is $132.50. We're going to plug that in for Y. $132.50 is equal to $20 plus $4.50 X. So as we go through to solve this, draw your river, put a box around the $4.50X. We're going to subtract the $20. So you're basically subtracting the sign-up fee. So when I subtract $20, I end up with $112.50. So it's $4.50 per class, so we're going to divide up the $4.50 to see how many $4.50s we can fit to that $112.50. And when we divide that out, we end up with an answer of X equals 25. So the number of shirts is going to be 25 shirts. I'm sure I just said classes a minute ago thinking of the previous problem, but X equals 25. Okay, Math 8, because of time, I'm going to just go ahead and put up the answer for the next one. And you can, hopefully you'll be able to. Okay, so I'm just going to go ahead and put the answer up here for number 4. Without explaining it, hopefully you can pause it and try it on your own. And by this time be able to figure it out. Okay, so the independent variable is going to be number of people at the party. The dependent is the total cost. The equation that you're going to write is going to be Y equals flat rate of $55, and then you pay $8 a person. Okay. So when we take a look at your table, again, you want to make sure your table is labeled. So this is cost, number of people, and in the Y column, it's 55, 63, 71, and 79. You can go over here to your graph and you would plot it. So 0 and 55, 1 and 63, 2 and 71, and 3 and 79. So actually let's fix that. There we go. So 71 and 79. Very close. Okay. Now to do your equation, it's going to be Y equals $55 plus 8 times 12. Put that in your calculator, and the total cost is $151. And if you have a party that costs $175, you plug the $175 in for Y. You're going to subtract 55. And you'll divide both sides by 8. And you're going to find X is equal to 15. So how many kids attended? 15 kids. Okay, Math 8. Hopefully this will help you with your lesson as you work with your book on lesson 3-5, writing an equation and making a graph. Have a good night.